So, hello students, again we are back with some topics of digital electronics, that is multiplexer. In electronic circuit, multiplexer has a many use, and in modern digital electronic, multiplexer is a very important topic. So let's start. So what is multiplexer? You can see the word here, many is to one. What does it signify? All of we are very much accomplished with the term multiplex. What is multiplex? Multiplex is just a cinema hall. The theater is shown where many movies are shown. We have to select one. We have to choose one, and we can see only one at a time. Similarly, in multiplexer, the many is to one stands for there are more than one input, many number of input, but the output will be a single one. What will be the output? That is the basic logic, and you have to learn it very quickly, and it is very easy topic, multiplexer. So here we can see from the block diagram, there are some few select lines by which we can select a particular input which will be transferred into the output. So if n number of select lines are there will be total input is 2 to the power n. So for only one select line, the input will be 2. For only two select line, the input will be 4. For three select line, input will be total 8. For four select lines, total number of input is 16. But the output remains only a single channel, only one output. Okay, now the question is that how it works. What are the function of this select line? How and which input transferred into the second one? So first, let us take a view. The most easiest 4 is to 1 marks. How it works? What is its truth table? How can it be implemented by some basic logic gates, that is AND, OR, and NOT? So let's start. So this is a 4 is to 1 marks where total number of input is 4 and output is 1. So if the total number of input is 4, so what will be the number of select line? The number of select line will be 2, because if we have total n number of inputs, if we have total n number of select lines, the number of input will be 2 to the power n. So if I have 2 number of select lines, the total input will be 2 square, that is equals to 4. Okay, now this is the basic truth table of 4 is to 1 marks. So S0, S1, 2 select lines, so total number of combination will be by this is 4. So what are these? 0, 0, 0, 1, 1, 0, and 1, 1. Now, when S1 is 0, S0 is 0, the output will be D0. Whatever the input applied at D0, it will be reflected in your output. If the select line is remains 0, 0, if then D0 is 0, output will be 0. If D0 1, output will be 1. So whatever input I am applying at D0, the same output will be shown in Y, that is output. Now, if the select line is chosen as 0, 1, similarly, the input of D1 will be passed to the output, that is Y. Whatever input I will apply to the D1, it will be reflected in your output. Similarly, for 1, 0, whatever input in D2 is given, it will be reflected in your output. If the arrangement of S0 and S1 is given as 1, 1, then the output will be D3. That means if I apply 0 at D3, the output will be 0. If I apply plus 5 volt or logical 1 at D3, the output will be 1. So that is the basic truth table. So what is the expression of that y? You can see here is 1 is 0, is 0 is 0, then output is d0. So in that case, the output will be d0 into s0 bar into s1 bar, or that or means plus. When it is 1 0, s0 is 1, then output is d1. So it is d1 s1 bar s0 this one, or that means plus d2 s1 s0 bar. So here it is, or d3 s1 s0 this one. So that's how we can easily implement this output. We can easily express the output in the form of the inputs and the select lines. So if I once get the expressions, similarly I can have the circuit diagram using and or not get basic gates. I can implement this multiplexer. Let us consider S1 and S0 is your select line, D0 to D1, D2, D3. These are your inputs and Y is output. So D0 is 1 bar is 0 bar. Where it is? This is D0. This line is D0. This connection is for S1 bar. This connection is for S0 bar. And they are the input of a AND gate. So the output will be this one D0 S1 bar S0 bar. Now I have to design this one D1 S1 bar S0. So this is my D1, this is S1 bar, and this is S0. So the output of this AND gate is D1 S1 bar S0. Similarly, we can implement D2 S1 into S0 bar and D3 S1 S0. So all these are the inputs of the a final OR gate, because there is a plus sign is there. So all the output from these AND gates are fed to an OR gate, and the output of that OR gate is my final output Y. So that's how you can implement multiplexer by using AND or NOT, that is basic gates, very easily. Similarly, you can go for the higher order, that is 8 is to 1, 16 is to 1, get very easily. Just try to understand that, and it will be very much in your very important for your curriculum for designing any circuit, and you can easily implement. Just understand how to implement this 4 is to 1, and you can implement 8 is to 1 as well as 16 is to 1 and more higher. Now I will make you learn how a higher order multiplexer can be implemented using a lower order multiplexer. So here I have shown how to implement a 16 is to 1 multiplexer using 8 is to 1. Now this is the basic diagram. Okay. So 218 is to 1. So 18 is to 1 means 8 is to 1. So here is 8 input and here is 8 input. So there are 16 input already there. No need to worry. But this is giving one output. This channel is also giving one output. And finally I have to make it one output, so I can easily make it or get connection to have the final output. But the main problem is where? The main problem is in your select line, because in that 8 is to 1 there are 3 select lines. Also in this 8 is to 1 there are 3 select lines, so total 6 number of select lines. But I need to have only 4 select lines. because I have to implement 16:1 marks. So 16 is 2 to the power 4, which give me 16, right? So I have to make 4 select lines. So what I have done, I have made S0, S1 and S2 short. So 3 select line is already there. Now the highest, that is the MSB of these select lines. How can I implement this? Just remember the truth table. If I want to select any data between D0 to D7, my S3 should be 0 because the D0 has a binary digit of 0000. And if I want to select D7, I have to give 0111. If I want to select D0, I have to give 0000, D1 0, then 001, 42 0, 1 0 1 0, 43 0, 0 1 1, 44 0 1 0 0, 45 0 1 0 1, 46 0 1 1 0, and 47 0 111. So on that case, for this multiplexer, first one, S3 should be 0. So it is set to the enable bar signal. So whenever I am applying 0, if this one is active and the NOT gate is there, so in whenever I'm selecting D0 to D7, it is 1. This signal is 1, so this one is completely deactive. And the whatever output I need, I can pass from here. If this one is 1, output will be 1. If this line has 0, the output will be 0. Similarly, for higher order from D8 to D15, S3 is 1. So when S3 is 1, this one is deactivated and this one is selected, and the higher order, that is D8 to D15 inputs are selected, and the output will be passed through this channel and it will be reflected in final output. That's how I can easily implement higher order multiplexer with lower order multiplexers. So that's very easy. Try to do it your own. And now I am moving to the final use of these multiplexers. This is how can I implement any Boolean function using multiplexer. Now, first of all, there is a question that implement f of abcd, that is the summation of these mean terms, that is 0, 1, 3, 4, 8, 9, 5. So from 0, the lowest one, from the highest one is 15. So basically from that function, you easily know that there are 4 inputs. Whenever there are 4 inputs, I have to take 3 select lines and 1 as the operand in the input. If I would have the 5 inputs, then there will be 4 select lines. So 4 select line means I have to use 16:1. In that case, 4 inputs, I need to left one and other 3 will be your select line. So 3 select line means 8:1 marks. Okay. Total number of, from the total number of operand, you have to left one and others will work as your select line. That's your basic funda. Now remember this one, 0, 1, 3, 4, 8, 9, 15. So 3 select lines. So 8:1 marks we have to use. Okay. This is the figure of an 8:1 marks. So BCD, you can see the 3 select lines. One output is there. Now what I will have to apply at these D0 to D7 inputs, 8 inputs. First, you have to build a table like this, where in the row there will be A bar and A. There are 4 operands, out of which BCD are select lines, and A will be acting as your combination of inputs or some inputs or other inputs may be applied. Now, how I can apply these inputs, input of A in D0 to D7. Just in the columns, there will be 8 columns, that is D0 to D7. In the row, there will be first one A bar, and in the second row will be A. Just write down these numbers 0, 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14, and 15. Now, what was the question in the meantime was 0, 1, 3, 4, 8, 9, 15. So just mark this 0, 1, 3, 4, 8, 9, and 15. I have already encircled that, and now I have marked it with the yellow marker. Now in the D0 column, you can see both 0 and 8 are encircled. So in the D0, we will apply 1, that is plus 5 volt, logical 1 or plus 5 volt. In D1 column, again you can see that 1 and 9 both are marked. So whenever they are both the variable is marked, I need to apply 1 or plus 5 volt. But in case when in the column D2, in case where nothing is marked, nothing is encircled, you have to apply 0 or make it a ground. You have to make it you have to make it ground or give the logical 0. Now in column D3, you can see only 3 is marked, and this is the row of A bar. So in D3, you have to apply A bar. Same for D4. Nothing is marked in D5, so it will be 0. Nothing is marked in D6, it will be again 0. But D7 is one variable is marked, that is 15, and it is in the row of A. So in D7, you have to apply A. So in D7, you have to apply A. So you can see here in D0 and D1 plus 5 volt as per your table, and in the D2, D5 and D6, these are all shorted and they are grounded. That is logical 0. D7, A is applied at D7, and D3 and D4 are shorted, and A bar is applied with the help of a NOT gate. So that's how multiplexer works. That is very easy to implement. As you can see, the truth table is very easy. Working principle is very easy. You can easily implement with the help of basic gates, that is AND or NOT. You can easily implement higher order multiplexer using your lower order mux, and you can also easily implement the Boolean functions or any digital functions with the help of your multiplexer. So that's how multiplexer plays an important role in making a digital electronic circuits. So thanks for today. Go study and make this ECE or electronics communication engineering very easy. So easy, stay easy with your ECE. Thank you.